Welcome back. Let's do question 9.2. In the diagram below, D, E, and F. D, E, and F are points on the circle at Q. AGF is a tangent. AGF is a tangent to the circle at F, at this point here. ED is produced. This is ED. It means extended to meet the tangent at A. And then B and C are points on AE such that GB is parallel to FD. GB is parallel to FD, already indicated there. GC is joined. GC is joined. We have GC there. And then GCDF is a cyclic quad. FQD is 2x. We need to look at the information and fill in the writer as much as we can. Right, it says that in the diagram below, D, E, and F are points on the circle at Q. AFG is a tangent to the circle. So now we have to think of the tangent theorems. We have to look at the tan chord theorem and also tangent perpendicular to radius. Okay, and then we're also given center Q here. We're given center Q, so also think of the center theorems. An angle at the center is 2 times the angle at the circumference. Or a line drawn from the center perpendicular to the chord will bisect the chord, but we don't have that, I think, here. And then a line from the center to the midpoint of the chord is perpendicular to the chord. We don't have that here. So think about that. It is produced to meet the tangent at A. B and C are points on AE so that GB is parallel to FD. Right, check. GB is parallel to FD. We can see triangle ADF. We can see triangle ADF. So it means here we may use the proportionality theorem somehow. Okay, all right. And then GCDF is a cyclic quad, so it's not indicated. We are told that it's a cyclic quad. Let's sketch our circle. All right, if we have a sketch like this, it will assist us a lot. Okay, let's fill this information as much as we can. We're going to look at the questions later. We're given 2x. Let's look at what we are given. We're given the angle 2x. So this angle is going to be x because angle at the center is 2 times the angle at the circumference. Right? And then if you check using the tan chord theorem, this should be x also, isn't it? That should be x because we have the tangent AGF and then the chord FD there. So F1 and angle E must be equal. Tan chord theorem. What else? This angle F2 should be equal to angle D2 because of the radii there. Right, we're told that GCDF is a cyclic quad, so this is a cyclic quad. So it means this angle X is equal to this angle C1 because C1 is the exterior angle of a cyclic quad. So this should be X also. With this information, let's try to answer the questions. Give a reason why angle E is equal to X. This is angle E, so we've talked about that. So you're saying that angle E is equal to X since angle at the center is equal to 2 times angle at the circumference. Right, 922, we're required to prove that GC is parallel to FE. GC is parallel to FE. If we check, we've done that. How do we prove that the lines are parallel? Right, we can prove the lines are parallel if the corresponding angles are equal. We can prove the lines are parallel if the alternate angles are equal. And also we can prove if the lines are parallel if the co-interior angles are supplementary. So now we proved that angle C1 is equal to angle E. Remember we discussed this, isn't it? But let's write there in our answer nicely. So we're saying that angle F1 is equal to angle E, and then both of them are equal to angle X. Why? Because of the tan chord theorem. And then remember we're told that GCDF is a cyclic quad, and then we say that angle C1 is equal to angle F1 since angle C1 is the exterior angle of a cyclic quad. So angle C1 is equal to angle F1 and both of them are equal to X, and then there is an exterior angle of cyclic quad. Angle C1 is equal to X and then angle E is equal to X. So what does that mean? We have angle E1 equal to X, angle C1 equal to X. Therefore, angle C1 is equal to angle E. I usually use this reason and say if x is equal to 3 and y is equal to 3, therefore x is equal to y, because they're equal to the same thing. E is equal to x, C1 is equal to x, therefore angle E is equal to angle C1. Okay, so now we have these corresponding angles C1 and E being equal. So we can say therefore GC is parallel to FE. And then the reason we write, we say corresponding angles equal. Okay, so these two lines are parallel because the corresponding angles are equal. Alright, 923, prove that AB over BD, that's AB over BD is equal to AC over CE. Right, let's check what we have here. We just proved that GC is parallel to FD. Again, we have triangle. We have triangle AED. Right, so we have two triangles now where we can use proportionality theorem. We have triangle ADF. You should be able to see that triangle ADF. And then we have triangle AED. Let's look at triangle ADF. Looking at triangle ADF, we can say AB over BD is equal to what? AB over BD is equal to what? Is equal to AG over GF. Right, and then there is in line parallel to one side of triangle. Right, so we have AB over BD. Now we need to introduce AC over CE. If we check again, triangle AEF. Let me highlight it using the light blue ink. So this is the triangle we're talking about, the bigger one. FE is parallel to GC. You see that? So we can talk of AC over CE being equal to AG over GF, isn't it? Okay, AC over CE is equal to AG over GF. Right, then line parallel to one side of triangle. Right, so now again we're saying AB over BD is equal to AG over GF, and then AC over CE is equal to AG over GF. Therefore it means these two are equal. So therefore AB over BD is equal to AC over CE. It is further given that AB is 12 units. AB is 12 units, so we have 12 units here. 12 units. And then CE is 22,5. Where is CE? CE is 22,5. CE is 22,5 units. And then we're given that 5 AG is equal to 4 GF. Then determine the length of CD. We want to find this length here. We want to find what this one is. Remember, we just managed to find that AB over BD is equal to AC over CE. But we have this 5 AG is equal to 4 GF. Remember, we say that AB over BD is equal to AG over GF from the previous one, okay? Because of line parallel to one side of triangle. And then we also said AC over CE is equal to AG over GF. Again, line parallel to one side of triangle. Now from this statement here, 5AG is equal to 4GF. Right, if you say 5AG is equal to 4GF. So it means we can divide by GF on both sides and then get 5AG over GF is equal to 4. And then divide by 5 on both sides of the equation, and then we get that AG over GF is equal to 4 over 5. You see that? So we have this. So it means that from this we can say AB over BD is equal to 4 over 5, and then AC over CE is equal to 4 over 5. So if AB over BD is equal to 4 over 5, then also AC over CE is equal to 4 over 5. but we're given AB. We're given AB. AB is 12 units, and then CE is 22.5. Right, let's substitute what we're given here. So we have AB, which is 12, so 12 over BD is equal to 4 over 5, and then AC over CE, which is 22.5, is equal to 4 over 5, right? And then what we do from there, right? We can find BD, we can find AC, right? How can we find BD? We can cross multiply here and find that 12 times 5, that is 60, is equal to 4 times BD, which is 4BD, right? Meaning that BD is equal to what? Meaning that BD should be 15, right? 15 is equal to BD after dividing both sides by 4. And then cross multiply here, 22.5 times 4, that is 90. 90 is equal to 5 times AC, 5AC. Then divide by 5 on both sides of the equation, you must get 18. So AC is equal to 18. So now we manage to find that BD is 15, and then AC is 18. AC is 18. This is 18. Alright, okay, this is 18. So it means from AC and AB we can find what BC is. Alright, so BC will be equal to, BC is equal to 18 minus 12. So BC is equal to 6 units. Okay, so now this one is 6 units here, 6 units, right? And then remember, we're finding CD. We can find CD by subtracting BC from BD, because we have BD, which is 15. So we can say BD minus BC, we get CD. So therefore CD is equal to BD, which is 15, minus BC, which is 6. So it means CD is 9 units.